Okay? So instead of increasing a number by a percentage or decreasing a number by a percentage, we're going to be given the number, the new number, and we're going to work backwards and find the original number that we started with. Yes?
Have we already done this?
No. We've done increase and decrease, but we haven't found the original number. Okay? So, but we are going to refresh just for those of you who went camping. There you go. That just refresh a little bit. Remember, when you're finding increase, you take 100% plus the added percent, right? And then you multiply that times your original number to get the new number. You don't have to. This is just refreshing us, so you don't have to write it down if you don't want to. Oh my God, you almost had to write. You almost wrote down something? Yes. Because God forbid you should waste the pencil lead to write this down. It's okay. I'm all right. All right. So remember, increase. Yes. You don't have to write this down if you know it.
If we have it written down.
You have it written down somewhere else. Yeah. Okay. Right? So we took 100% and the added percent, whatever it was, 40%, 50%, 130%, whatever. Added those together, right? But when you get a percent, can you multiply with a percent?
No.
We had to change it to a decimal. And that times the original number gave us the new number. Can somebody remind me then? Again, you don't have to write this down if you've already got it down in your notes. How to do decrease? What did we do? What if it was a decrease? What did we do?
You minus 100.
We took 100% minus, the decrease percent, right? Times the original. Okay, and that equaled my new number. Remember that? So if you're increasing, that means you're adding to 100%. If you're decreasing, that means you are subtracting from 100%. Always from 100%. That's the key there that I'm trying to find. Okay? That one. Yeah, that. Okay? Percentage of increase or percentage of decrease, right? Okay? So what we're going to do today is we are going to go backwards and look at finding the original amount before you increased it or decreased it. Okay? So, going backwards, right? And that's the key. So if you decreased, we're going to go backwards and not subtract, but what do you think? Add, all right? Add. And then, okay, so let's go back here. Let's just do increase first. Remember, increase was add, then multiply, right? Isn't that what we did? We added the percentages, then we multiplied times the original number. Isn't that what we did?
I thought this was the one where you define the original number.
Well, we're not done. We're not doing the... Yeah.
Is that a different topic?
Yeah, that's a different topic.
Oh.
All right? Now, for decrease, we subtracted and then multiplied, right?
Can you give an example of both?
Mm-hmm. So let's say we wanted to find 120%. Okay. No, not of. Say we wanted to increase 30 by 20%. Remember that? Okay. So first of all, we'll take the 20% and add what?
100.
Right. Which gives us 120%. And times the 30 is our original number, right? Okay. Can't multiply with that. Change it to a? So that's what?
1.
So 1.2 times 30, which gives us, somebody with a calculator?
24. She was joking.
36. You were so close. Yeah, you just said decimal in the wrong place. Right? Remember that? Now, What if we were decreasing? Instead of adding, I would
Minus.
subtract. Right, there you go, minus. Okay, so 80%, which would be 0.8 times the 30, which would give us a number lower, so it would be 24. Right?
Yeah.
Okay? Yeah, you did. Okay. So, now remember, this was giving us the new number, right? Our new amount. But what we're going to be given is, we're going to be given the new one and told how much we increased or decreased it. And we're looking backwards to the original. So, instead of adding, then multiplying, what do you think I'm going to do? Boom. There you go. We're working backwards. And instead of subtracting, then multiplying, I would add, then divide. The opposite of divide. So close. Okay. All right. So let's take a look at the Education Perfect. That reminds me. Okay. So after we increased it by 20%, we ended up with 90. Okay? So is 90 what we started with? No. 90 is what we got after the increase. Right? So that means our original number has to be lower than 90, right? So we're looking for a number that's smaller than 90. Okay? Well, if we increased it by 20, right? That means we would take 100 plus 20. That's how to increase it by 20. But we don't want to see the increase of 20. We want instead to do the opposite. So I'm not going to... I don't know why I keep doing that. So the current size of the number is 120% of the number. And we're going to take that decimal times the original amount equals the 90. So hold on a minute. Just look at the pieces first. And then we'll go through a whole problem and do steps. Okay? Yes, I will write out the steps. Okay. So, are we ready? Yes. Of course I'm going to write out the steps. You know me and steps. All right. So, here we go. So, the new number, okay, here's what we need to do. Okay? Yeah, these are the steps. All right. Step 1, to find the original. Let me rewrite that to find the original. Hold on. Get a grip. To find the original. Okay? All right. Okay. First. Now. Increase means that it's bigger, yeah? And so since they give us the amount of increase, that means we have that percentage. So just take 100% plus that percent, okay? And that's going to give you the current size. Now we're going to go backwards from there. I'm sorry, I was misleading you a little. We're still going to add them together. They're doing it a little slightly different. Go ahead and add them together. So that's the same. Second, instead of multiply, we divide the number by that percent, or that decimal. Let's write it as a decimal because we don't want to put... Just write it down and hold on, and we'll do it, and I'll show you. It's very simple. By the decimal to get the original. 2 steps. Okay. We added 100% to the percent, just like we always did. Okay? So 100% is 20%, because we increased this number. Okay? All right, so here we go.
Yes.
So let's just do this one on a blank piece of paper. Okay. Oops. Get rid of all this stuff. Okay.
Oh my God.
Hold on. So we've got 90 is 120% of some number? What is the original number? I'll just write out number for you because I know it freaks you out if I do symbols. Yes, I want you to write this. Now, this is the key right there. What is it that I'm looking for? The original number. That means I'm not multiplying. I'm going to go backwards and I'm going to divide. So here are the steps. Okay. 90 is 100%. What number? So 100%, 120%. I've already added the percentages. Okay. I can't So normally, if I was taking a percentage of a number, I would be taking 120% times the 90. Thank you. Times the 90. But I don't want the new number. I want the original number. So I'm going to be doing it backwards. Instead of multiplying, I will be what? Divide. Okay. So first, okay. In this case, we already have 120%. If normally it would say some percentage of it. We'll do plenty of examples, and you'll be going, it's so easy. All right. So it's 120% is what as a decimal? 1.2. Right? And what is my new number? What is the number that I have? 90.
Sorry.
Yes.
Can we slow the steps?
Okay. Well, all we did so far is just change 120% into a decimal.
Yeah, I know, but we were rushing into 2 and I just...
Okay, that's all right.
Got a bit scared.
Don't get scared. It's easy. Okay? Okay. Are we ready? Now, what is my number?
90.
But that's not the original number, so I'm not going to multiply it times there. I'm going to instead what? Divide. And that part you'll just do with your calculator. So 90 divided by 1.2 is?
75.
Sorry? 75? I don't know. Okay? And that's all there is to it.
So the original number is 75.
Right. So 75 is the original number. So think about it like this, okay? Now that I have all three pieces, I can explain it in context. You go into this shop, right? All right. And they're going to raise the price on you. So it started off being $75. They increased it by 20%. And remember, an increase of 20% means really not 20%, but what? 120%, because it's the original price and the increase, right? And they increased it by 20%, which means multiply times 120. And that's how they got the 90. But what we're doing is we're going the opposite way. What number did I start with? Okay, so let's say you own the store, right? And you want to make a profit. So you paid $75 for this thing, but you want to make a profit on it, so you raise the price up for the person that's buying it, right? Okay? And usually that's done using a percentage. But instead, this time we're looking for the original price. How much did they pay for it? Okay? All right. Let's look at some more. It's not hard. All you have to do is remember that if it says the word, if you see the word original number, then don't multiply it like we did before. What do? Divide it. It's the only difference. Okay? Original amount or original number. Yes.
What does it say down there that it times it?
They're just showing you what you would have done if you had the amount. But did you see that they have the words original amount, right? Not a number. If you had a number there, you'd just multiply it like you always did. Okay? So they're solving it like an equation. Remember, if you had an equation, you'd do the opposite. What's the opposite of multiply? Divide. And that would make those go away and tell you that the original amount is equal to those two numbers. But instead, you can just remember that the opposite of multiply is divide. Okay? All right. Let's look at some more of these. You're gonna be so happy with these. They're so easy. But you've got to watch out for the phrase, okay? So look at what this says here. We can use the same process to find the original amount. What is my key phrase there? Original amount. That means I'm going backwards, which means not multiply, but what? Divide. Okay? To find a percentage decrease. Let's say we have an amount and we decrease it by 25% to get a result of 120. So 120 is not what we started with. 120 is what we got after we did the math. Right? So I want to know what was the number before we did the math. Okay? Well, it was a decrease of what? Which means a total amount of 75, right? So it's 75% of the number. But we can't work with 75. We have to change it to a decimal. What's that going to look like as a decimal? 0.75, okay? And so it would have been 0.75 times the original amount, but I don't know the original amount. So instead of multiplying by the original amount, I can simply divide the new amount.
Do you always put on the bottom?
Yes, because that's what divide. Remember, the fraction bar literally is the division symbol, right? Yes. So it's simply 120 divided by 0.75. And what do you get when you do that? Anybody? So 120 divided by 0.75.
No, I was wrong.
It's 25% off. Would you get 160?
Yeah, I did. Oh, I thought we didn't want it to be bigger.
No, it's going to get bigger. Why?
Oh, because we decreased it.
We decreased it originally, so it's going to be bigger than what we started with. Right? We're going backward. Don't let it be confusing.
Oh, I can't help it.
It's okay. All right. So it's okay. I'm sorry. I'm not judgy. All right. All right. So if you're looking for the original, you're not going to multiply it. You're going to what?
Divide it.
That's all there is to it. Okay? Now, see, there you are. 160 was your original number.
Right.
Okay? All right. Here we go. Let's try some examples. They knew that this would make it, flipping directions always messes with everybody. Okay? Let's try some examples. Find the original amount. Original amount means that I'm not going to multiply. I'm going to what? Divide. Okay? So that's the key. If you see original amount, that means I'm going to divide. Right? And that's the key to the whole thing. If a number has been increased by 42.5%,
Such an unfortunate number.
it is a horrible number. But that's okay, because that just means 42.5% plus what? 100%. Now, when it's not a decrease, it's an increase, right? So we're adding. So 142.5%. Which we have to change to a decimal. You're perfectly right. Which gives us 1.425.
What?
Oh, sorry. I did not do that.
Wait, I need to write this down.
It's a wackadoodle number. But right, you never change. The rules never change. That's the beauty of the math. The rules never change.
Question.
Yes?
If it's increasing, it's always plusing, and decreasing is minusing. Okay, so it's not. Okay.
Yeah. All right. So, what's our new number? No, here we have 57 is what we started with. Divided by what?
140.
And what does that give me?
40.
So that means the original number I started with was 40.
Yeah.
So 40 increased by 42 is 52. Interesting. I see.
If you did it the other way around, if you did what we did last time. It's been a while since we did this too, guys.
Were we supposed to learn this at like primary school? Because
I did it.
Are you making this as a recap?
This is
like
the
you
first
teaching us. This is the first
I
year
find
I've
it
done
easy.
this.
I feel like everyone's
everything in this number section is supposed to be revision.
I feel like teachers always assumed I knew it, so they didn't tell me, but no one told me.
Well, guess what? I assume that y'all don't know anything.
You were right.
And therefore, you're going to, and which is not so good for some students. Some students get mad at me because I take up the knot hole. But the rest of you, you're going to be fine. All right, so, yes, this is something that you would have done in much earlier grades. Not primary school, not junior school, but middle school, certainly. Okay. This would have been on the number test in year 9.
I don't think anyone would like the method for it.
Yeah, I just figured it out somehow myself, and then there we go. And it might have been right.
Hope for the best.
Okay, well, I don't ever hope for the best. I want you to know the rule. So here you go. You see, because it's an increase, that means we're adding, right? Stays the same. But instead of multiplying, we're going to divide, and that gives us our number. All right? Want to do another one?
Yes.
Find the original amount if the number has been decreased by 60% to get 88. What's my key phrase there? Well, there's two key phrases, but the first one is original amount. There you go. That tells me original amount. Okay? So, first of all, who can tell me what decreased by 60% means? 100% minus 60%, which is 40%. Okay? Right. I can't ever multiply with a percentage. I have to change it to a decimal, which is what?
0.40.
Okay. Now, but I'm looking for the original amount, which means I'm not multiplying, but what?
Divided.
So what was my number up there?
Yeah, that's not right.
88 divided by what?
Oh, there's an 0.
0.40 or 0.4, whatever, equals?
4.54.
Is that what you got?
Oh, yeah.
That looks very odd.
I got 45.4545.
Ah, there you go. There you go. What did you get?
45.4545.
45 point.
4545.
Stop doing that.
Oh, no.
4, 5.
6, sure.
Okay. Messing with me there. Okay. Okay. Blah, 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 blah. It repeats, does it?
Yeah.
Okay.
You are so right over there. I'm not figuring it out at all. I know. I did.
Now, come on. How do we know that her 45 is not correct?
Because it's not bigger.
This number was decreased to get 88, so it's got to be bigger than that, right? So go back. 88 divided by 0.4 is what?
250.
There you go.
See, I
Okay.
Oh.
What did you do, you think?
See,
Did you multiply times point?
no, I didn't. I knew about the divide. It was the instead of 0.4, it was 0.88. So I just a little switchy.
Oh, you switched the numbers. I see. Okay. There you go. The original number was decreased, yeah, so it should always be bigger, right? Then it should be a smaller number because you went bigger. All right, is it looking any better? Is it just because it's Monday and we haven't been here in a while?
Period.
Because y'all haven't been like this before. It's starting to scare me a little.
Well, I just haven't seen it out loud. It's not confident enough to say how we feel.
It's starting to scare me. Well, I'm glad. I want you to tell me how you feel.
You were supposed to be not scared.
Okay. All right. So there you go. So there's the calculation. So the original amount was 220. Okay. Okay. All right. Here we go. All right. Now this is in your homework, but we'll see what we're doing. So select the correct percentage and decimal that you would use as a multiplier to increase a number by 40%. If you were increasing a number by 40%, increase by 40% means...
Well, like the number 100% plus 40%. It's not 140. So it's number.
Well, 140%, but would that be the multiplier?
No,
1.4, because you can't use the percent. That's the correct percentage, but remember, the multiplier would have to be a decimal. Okay, do you think they'd both be correct? Correct percentage and decimal. Okay, yes. So you want both of them. So you want that one and that one. Thank you very much. If I wasn't reading, I wasn't paying attention. Imagine that. Just like when a pig stole my luggage. All right. That's pretty funny. Oh, I chased the, yeah. Okay. Here we go. All right, here we go. Now we're going to look at some situations where we're looking for the original amount. But your key is that original amount. And they're going to have to give you a percent, and they're going to have to tell you whether it was an increase or a decrease. Right? They have to give you the same information. With this time, we have to pull it out of a sentence instead of them just reading it to us. All right, here we go. First, let's go through a couple of examples. Here we go. And a one-night stay at a motel cost $130. Okay, which includes a discount of 20%. Discount means that they decreased the original amount by what? 20%, right?
So it could have been $200.
So, yes, you bet. So 130 is cheaper than the original amount by 20%. So that's 100%, what?
Plus 20.
Ooh, be careful.
Minus 20.
Discount.
Oh, so 80.
Minus 20% gives us 80%.
It's 1.
Which we can't use we have 0.8. Good. Now, is the 130 how much I paid or how much it was originally? The 130 is how much I paid. We're looking for the original, right? So I take 130 divided by 0.8, and what's that going to give me, guys? So the room originally cost $162.50.
Yes. Yes, it did.
But we got it on sale, right?
Oh,
Yeah.
Yeah.
That was the sum.
That was the sale. Right.
Wow, that was great. Now I understand.
Math is easy. The math is easy, yeah?
But now my friends now thinks about other one where it was things changed. And she was like, change this.
Okay. Well, here the key here is right here. That means they've already given you the discount. This is the discounted amount, right? So that means we're looking for the original amount.
So with the other one that we did last time, it was
We were finding the new amount, right? So they would have given us the 162.50, and we found the 130. Okay. All right. Now remember, we will look at how these look on the NCEA test too before you have to take it too. All right. So there you go. So 100 minus the 20% gives us 0.8 times the normal price, which is really the same as divide. And there you go, 162.50. Ready? Here we go, guys. Here we go. A jug had an amount of water in it. Water was added to increase the volume by 122%. Be careful with this one. To a volume of 640 milliliters. So, 640 milliliters is how much we had when? Now, not to start with.
Like 300.
Well, we increased it, so we would have had, yes, so we're going to have less. Now, how much did we increase it by?
122.
Boom.
Add 100 to that.
Exactly, and that's what they're messing with you a little bit. It's unusual to add more than 100%, isn't it? So you've got to be careful. So it's really 222%. Okay, so don't think that they've already added it for you and because they would have had to say they increased the volume by 22% if they wanted it to come out to 122 at the end. All right, so you see, so be careful. Then they're going to mess with you doing that. So then that's 2.22, and what number? 640.
It's 288.288.
And here's something else.
Milliliters.
If you forget the units, the answer's wrong.
Wow.
So make sure if it has units, then you need units. Okay? That is funny. It repeats like that. Okay? And it just does it 288 or just 288?
And then it goes to a 3.
Well, that's because your calculator stopped, yeah. Okay? All right, so you see, there you go. Look at y'all. Doing it perfectly. Such a deal.
Yeah, I know.
Okay? I never had any doubts.
You had some.
I might have had a little doubts. I was doubting my ability to explain it properly is what was wrong. Okay? There you go. So then there's some where you're doing it. There's 72 cases, 80% more than normal. So that means the original amount was something else, right? Okay? More than. Does that mean an increase or decrease?
Increase.
So what's your multiplier? It's 180%, right? Right? That's more than, so an increase. Okay? What if it was fewer than?
Decrease.
Decrease. Okay?
So
Now that's your homework.
Increase, the number should be smaller. Like your,
Right. If you increase,
the original number
right,
should be smaller. The original number
should be smaller than what you got. You're exactly right. Yeah. It's like a little dance. Yes. So what? Oh, did you do this one? Okay. This one's your homework. Go ahead. What did you get? Because this one's actually in your homework. I don't know. Let's see.
I got 40. Unless it's not 40, then I don't know. It is. Look at my calculator.
Good job. Okay. All right.
Are we gonna get a book?
Yes.